Yes, good morning once again. Good morning, everyone. So this is another patterns of dimension, but this pattern is under differentiation. So the dimension of the SDT equals to what? Don't be confused whenever you come across this kind of question. A question can just come out in different forms, but don't be confused. Don't be confused when it comes to calculus and how to find the dimension of what of either integral or differential calculus. We've done the aspect of integral calculus, but this one is under differential calculus. Now, the SDT, what is the dimension of the SDT? We all know that differentiation of x with respect to t equals to velocity. That is, the SDT equals velocity, right? Now, we can see from this pattern, you can see that d is common, right? So the d we have here remains constant. So the d we cancel out, we cancel out the d. So d will be eliminated from the equation, remaining x over t. Now, what is the dimension of x? L. What is the dimension of t? That is the uppercase t. Dimensional symbols are written in uppercase or capital letters. So there is difference between lowercase t and uppercase t, small letter and capital letter. In terms of dimensions, all symbols must be represented in a capital letter. So the dimension of this will now be L t raised to power minus 1. So that's the dimension. So don't let the d confuse you. The d here remains constant and it will eliminate each other. The same thing works with acceleration. So when you talk about dimension of the square x dt square, you can see the square s dt square. What does that mean? You can see that the square x dt square is when you want is just like this the s we have here. The s we have here and we have t here. The d we have here, we eliminate out 1d, right? Remaining, we have d, right? X over t squared. Now, what is x? Dimension of x, that is the distance. The x here is L and t is what? T raised by minus 2. Now, look at the d here. The d we have here remains constant. So d remains constant here, which means d equals to 1. That's the dimension. So the overall dimension of this will now be L. Let me start from L now. L t raised to power minus 2. So that is the dimension of what? Of the square x dt square. That is acceleration. So that's just it.